Good morning. Today we're going to continue with what we were talking about yesterday with a little bit of a variation. Yesterday we were just given a certain trig function. We had to draw the reference triangle, use that reference angle to be able to find the correct one. Today's very similar, except what you are given. Today you are going to be given the terminal side passing through a specific point. So what we want to do to solve this, we want to begin by plotting that point. The ordered pair is 3, 6. So think about plotting that point. You're going to go over to the right 3, up 6. Here is the point. Now, draw the reference triangle in this quadrant. So from that point, draw a line to the origin, and then from that point, drop a perpendicular straight down to the x-axis. Your theta will always be what's inside the triangle, at the origin. That's theta. Now, the two sides that you just plotted, put those numbers on the triangle. 3, 6. We moved to the right. 3. We moved up. 6. From this point, we now are set up just like what we did yesterday. All we have to do is use Pythagorean's theorem. So we have x squared equals 3 squared plus 6 squared. That's x squared is equal to 9 plus 36. X squared is equal to 45. Take the square root of 45. So x is the square root of 45. Can that be simplified? Sure, we can break that down into two radicals. 9 times 5. Square root of 9 is 3 times radical 5. So this third side was 3 radical 5. So make sure that you're always simplifying your radicals. Now, once we have the third side, just like yesterday, answer your question. What's the exact value for cosine? Cosine, using SOHCAHTOA, cosine is adjacent over hypotenuse. Adjacent is 3. Hypotenuse is 3 radical 5. If you can't simplify, that would be your answer. If you can simplify, like in this case, the 3's will cancel, leaving 1 over radical 5. Rationalize your denominator. So we end up with radical 5 over 5. And that would be our exact value. Those are the types of problems we're going to work today. Let's do another example. This time we are given the ordered pair negative 6, 8. So let's begin plotting that point. We move left 6, go up 8. We have our ordered pair. Now, draw the reference triangle. We always draw it to the origin and drop it straight down to the x-axis. That creates a reference triangle. Our reference angle is always the angle at the origin inside the triangle. Now put your two numbers on. We moved left negative 6. So this number is negative 6. Moved up 8. So it's 8. Now, we would normally use Pythagorean's theorem to find the third side. But before, look, what trig word are we looking for? Tangent. Tangent from SOHCAHTOA is opposite over adjacent. Do we already have the opposite and the adjacent? So in this case, all we would have is opposite is 8, adjacent is negative 6. Reduce that gives us negative 4 thirds. Sometimes you don't have to find that third one if you are finding tangent or cotangent. Okay, let's do one more example. In this final example, we have the ordered pair 5, negative 12. So let's begin by plotting that point. We move to the right 5, we move down negative 12. Now, draw your reference triangle in this fourth quadrant. We draw a line drawn to the origin. It's perpendicular to the x-axis, and our theta is what is inside the triangle at the origin. Put our two values. We move to the right 5, we move down negative 12. Cosecant, that's reciprocal of sine, so we do have to know our third side. So set up x squared equals 5 squared plus negative 12 squared. So x squared is equal to 25 plus 144. X squared is equal to 169. Square root of that is 13. So our hypotenuse is 13. Cosecant is reciprocal of sine. Sine is opposite over hypotenuse. So opposite, the theta, is negative 12 over hypotenuse 13. Well, we need the reciprocal, so flip this upside down. Our answer would be negative 13 over 12. Okay, let me know if you have problems today.